welcome to I Love Physics. Here is the second lecture of optics. Before moving towards the lecture, subscribe my channel, watch the video till the end and like and share with your friends if you like it. So let's start the video. Thank you. Hello students, welcome to the physics lecture. I hope you have seen earlier video of optics, which is an introduction to what is optics, what is light, and how we perceive objects. Also, we saw that depending upon the nature of light, optics is divided into ray optics and wave optics. And also, we have seen the laws governing the ray optics, which states that light is considered as a ray and it travels in a straight line path. Second law states that two or more rays can intersect at a point without affecting their paths beyond that point. And the third and fourth laws are the laws of reflection and laws of refraction. Now, before moving further, you must be aware about the important terms which are used in optics. Let us first consider what do you mean by convex lens and concave lens. Convex lens appears as bulging outwards, whereas concave lens appears as if it is bent towards inwards. Now here you can see that when light rays coming from infinity, like the rays of the sun, strike onto the convex lens, it causes the rays to meet or converge at a single point, which is called as a focal point, which we will discuss further. So the convex lens is called as the converging lens. Like you can see in the figure here, the light rays which are traveling from infinite, they are being focused at a single point, that is the focus. Now, whereas in concave lens, light rays approaching the lens from infinity diverge on passing through the lens and appear to converge on the same side of the lens. That is, they have a diverging nature, but they form a virtual image towards the same side of the lens, which is formed by convergence, or which appears to us that it is a converging lens, but it is actually a diverging. So the main difference between concave lens and convex lens is that concave lens forms virtual and erect image also at the same side of the lens, whereas the convex lens forms the real and inverted image but at the opposite side of the lens. Here you can see how the light rays are being converged by the convex lens and are diverged by the concave lens. Although the size and position of images formed in both the lenses are dependent on the distance of the object which is placed from the lens, which is given in the table in your textbook. So it is advised to go through the table which is given in your textbook, which says how the size and position of images that are formed varies depending upon the distance of the object. Now let us consider some terms which are used in ray optics. For reference, we will be using convex lens. As you can see, the parallel rays of light which are approaching the convex lens, they are converged at a point which is called as the principal focus. Now, what do you mean by optical center? It is nothing but the central point of the lens through which rays go undeviated. That means whenever a ray of light passes through the optical center of the lens, whether it may be a concave lens or a convex lens, it goes undeviated. Next is the aperture. Aperture is nothing but the opening or the diameter of that opening or of the reflecting surface of the spherical mirror through which a light passes. The overall opening which you can see here, that is from starting from this point until this point, that is called as aperture. Next is the center of curvature. Now, whenever you consider a spherical mirror or a lens, you can see that the lens is formed by a sphere which is cut. Let us consider this as a sphere which is cut according to the requirement, and if we complete the sphere and obtain the center of the sphere, this is called the center of curvature, which is nothing but the center of the imaginary sphere. We have to imagine a sphere from which the spherical mirror or lens is cut, whose center is considered as the center of curvature. Further is the radius of curvature, that is nothing but the distance between the optical center of the lens, that is O, and the center which we consider, that is the center of curvature of the imaginary sphere. The distance between these two is called as the radius of curvature, which is denoted by R. Further is the principal axis. Principal axis is nothing but the horizontal line which is passing through the optical center of the lens. Next is the pole. Now, pole is a point at which principal axis pierces the mirror. That is this point. Here is the principal axis which is approaching mirror. So this point is called as the pole, whereas O is the optical center. Considering further, here we are considering again the convex lens, where before which an object is placed. Let's see now, what do you mean by object distance? Object distance is nothing but the distance between the object and the optical center of the lens. It is denoted by letter U. Next is the image distance. Image distance is nothing but the distance between the lens and the image formed. Here you can see that the convex lens is used so we get inverted image, and at the side opposite to the side where object is placed. So this is the object distance and this is the image distance denoted by V. Next is the principal focus, which is the point at which reflected rays intersect or appear to intersect on the principal axis. Let us consider earlier example. Here you can see the parallel rays of light are being focused or are being converged at a point which is called as the principal focus. So that is the point where all the rays of light converge or appear to converge in case of concave lens. That is denoted by capital letter F. Now the distance between the principal focus and the optical center is called as the focal length, which is denoted by small f. Next is focal power. It is nothing but the ability of the lens to converge or diverge, like you use your cameras to zoom in or zoom out. So when you zoom in, you basically try to focus the camera over the small details of the object which you are about to click the image of. So that is nothing but the ability of that camera to converge or zoom in. That is nothing but the focal power, which is given by capital P, that is the inverse of focal length. So these were the terms which we will be coming across in all the further lectures. So go through it thoroughly. Also, you must be aware about it earlier, so just revise it. Next is sign conventions. Now, when you solve problems regarding optics or in the practical examples also, in the real life, when you are about to buy some lenses, you need to have knowledge about the power or the sign convention which you will be using. What does the sign negative and positive sign denote? So let us consider here. You must be aware about the Cartesian coordinate system. Here you are using same Cartesian coordinate system for sign convention of the lenses as well. So as you know, there are 4 quadrants in the rectangular coordinate system, in which the first quadrant has both x and y as positive. In the second quadrant, x has a negative component and y component is positive. In the third quadrant, both x and y components are negative, whereas in the fourth component, x coordinate is positive and y coordinate is negative. Now, how we will be taking into consideration the lens and the image distance, object distance here. Let me show you. If we consider the lens over the origin of the coordinate system, that is, let us consider origin as the optical center of the lens, that is O. Now if we consider object towards the left, always we consider object to be placed towards the left of the lens. So if we consider here an object, and this is the object distance, that is U, and the rays passing through the lens, they try to converge at a point where image is formed. So this is the image formed due to the convex lens. This is called as the V, that is the image distance with respect to optical center. Now as you can see here in 4 coordinates, the object distance is in the third quadrant, whereas the image distance is in the fourth quadrant, so object distance is always considered as negative, whereas image distance is always considered as positive. Just this much you have to remember. Let me consider again the sign convention, which states that all the distances are measured from the optical center, and figures should be drawn in such a way that the incident ray travels from left to right. As I said, the object must be placed towards the left side of the lens, so the light will be passing from left side to the right side. Next, x-axis can be conveniently chosen as the principal axis. The principal axis is chosen as the x-axis. Next is the distances to the left of the pole are negative and those to the right of the pole are positive. Like we saw, the left side lies in the third quadrant, so the distances will be negative, whereas the right side of the pole are lying in the fourth quadrant, so those will be considered as positive. The distance above the principal axis are positive while those below are negative. As we saw the object distance as image distance, there are questions where you'll be asked the object size and the image size, so you need to consider the same. You need to consider the y-axis, which will be positive in the second quadrant and which will be negative in the fourth quadrant. Now all these laws can be stated or derived with the help of a single rule, which is called as the Fermat's principle. Fermat's principle is nothing but it states that light chooses the shortest distance to travel, that is the straight line path. The straight line path is always the shortest distance which light opts to pass through. So in ray optics, it is always taken that light is traveling and in the form of ray, that is in the straight line path. It chooses only the straight line path because that is only the shortest distance and the fastest distance which it can cover. So that is the Fermat's principle. Now moving towards the next point, that is reflection from the plane surface. Now as you know that when you look into your mirror, you see an image of yourself which is the exact replica of you, correct? So does it appear the same or there is some difference? Of course there is some difference. That is nothing but you observe a laterally inverted image of yourself. Now what do you mean by laterally inverted image? Is you obtain an image which is inverted horizontally. That is, your right hand appears to be left and left hand appears to be right. Like here it is shown in the image, a boy lifting his left hand appears in the mirror as the right hand which is lifted. So although the image is exactly the same, the size, the features, the body dimensions, etc., all the things are the same, except the thing is that is the reflection is a inverted image of yours. So this is what we'll be seeing in the reflection from the plane surface. Now plane surface can be anything, that is polished surface or any other reflecting surface. It may be mirror or water. Let's see. Now the reflection from plane surface can take place in three ways. That is, as I said, reflection from any plane surface. It may be a plain shining surface or polished surface or any reflecting surface. Another is the reflection from a plane mirror, which you saw just now. Here it is nothing but a plane mirror from where reflection is taking place. Next is when the object is placed between two mirrors which are inclined at an angle theta. Now, if you place two mirrors at some angle theta, it may be ranging any from 0 to 360 degrees. So, when object is placed between two mirrors, so there forms n number of images which can be obtained with the help of a formula which is given by n is equal to 360 by theta, where theta is nothing but the angle between the two mirrors. Now, if this n obtained is even, and whatever may be the object's position, the number of images formed will be capital N, that is n minus 1. Similarly, if n obtained is odd and object is placed exactly at the angle bisector. Now, what do you mean by the angle bisector is, now suppose your angle between the two mirrors is 180 degree. Your angle bisector will be exactly at the center, that is at the 90 degrees. And if your object is placed on that angle bisector and the obtained n is odd, then the number of images formed will be again n minus 1. Whereas if the n small n is odd and object is not placed at the angle bisector but anywhere else, then the number of images formed will be n is capital N is equal to small n, that is 360 by theta. Now, what if n is not an integer? For example, it is not an integer, means that it may be 3 point something, 2.22, 3.56, etc. That is not a perfect integer. Then the number of the images formed is capital N is equal to m, where m is the nearest integer or the integral value, like and if n is 3.56, the number of images formed will be 3. That means it would be rounded off to 3. Or if the small n is 4.36, then the number of images obtained will be approximated to 4. So this was all about today's lecture. We'll be seeing some in the next lecture that how reflection takes place from a curved surface, that is a spherical mirror like the concave lens or the convex lens. So till then, go through your textbooks thoroughly, revise what part have been completed today, and we'll be seeing in the next lecture the reflection from curved surface. Thank you.